Assalamu alaikum dear students. I hope you will be doing good. Today we are going to study chemistry. It's the lecture from the month of April. It's the first lecture that we have to cover in the same month. So the chapter which we are going to study today is what have we done to the ozone layer. It's chapter number 11.03, page number 192 to 193 from your textbook. The topics which we are going to study today are ozone, the Earth's sunscreen, 1928, the first of the new wonder products, 1985, not so wonderful after all, 1987, they have to go, and a harsh lesson. First of all, before starting our first topic, I have to tell you that what is ozone. Ozone is an irritating pale blue gas that is explosive and toxic even at low concentrations. It occurs naturally in small amounts in the Earth's stratosphere, where it absorbs solar ultraviolet radiation, which otherwise could cause severe damage to living organisms on the Earth's surface. As you people know that whenever we use any substance like gas or liquid in higher concentrations, it can cause damage. But in case of the ozone, in lower concentrations, it can cause damage. And why it is called as sunscreen? As you know that a cloud blocks the heat on the hot day. Similarly, ozone layer in the stratosphere blocks out the sun's deadly ultraviolet rays. It acts as our planet's natural sunblock. Because ultraviolet radiations can damage DNA, it is potentially harmful to most of the living things like animals and plants. And sunscreens are also known as sunblocks that are used routinely in a form of lotions, spray, gel, foam, or other tropical products. These are meant to absorb or reflect some of the sun's ultraviolet radiations, and this helps protect against sunburn. Now let's start our first topic, which is ozone, the Earth's sunscreen. High above you in the stratosphere, about 25 kilometers up, there is a layer present called ozone. It is also called as Earth's sunscreen. It is a form of oxygen. It has the formula O3. It protects us by absorbing harmful ultraviolet radiations from the sun. The ozone layer is not really a layer, rather is a zone which is more abundant than elsewhere. If the ozone gets depleted or used up completely or diminished, harmful ultraviolet radiations will get through the earth and kill planktons. And what are planktons? These are the diverse collections of organisms that live in large bodies of water. They provide a crucial source of food to many small and large aquatic organisms such as fishes and whales. Or in other words, planktons are the tiny sea plants that are basis of all food chains in the sea. So the fishes and other sea creatures will starve and their growth will be stunted, means they won't grow properly. This will cause the shortage of food, and ultraviolet radiations can also damage our eyesight and can also cause skin cancers in humans. 1928, the first of the new wonder products. 80 years ago, it was believed that refrigerators could kill us. Why is that so? Because refrigerators used harmful gases as coolants. And what are the coolants? Coolants are basically the substances or typically liquid or gases that is used to reduce or regulate the temperature. So the gases that were used as coolants are ammonia, sulfur dioxide, and methyl chloride at that time. Their small leak could be fatal. So anyone who came up with a safe fridge gas would be onto a winner at that time. So in 1928, an American chemist named Thomas Migley came with a new compound called chlorofluorocarbon or CFC. This CFC consists of chlorine, fluorine, and carbon gases. It was a wonder product, no doubt, at that time because it was non-poisonous, unreactive, non-flammable. That means it cannot catch fire, and cheap and easy to make. So it was a great success at that time. Soon a range of CFCs was developed. CFCs found more and more uses as coolants in the refrigerators and air conditioning units, as propellants for aerosols and cleaning fluids. Propellants are basically chemical substances used in the production of energy or pressurized gas, which is subsequently used to create movement of fluid. So they were used to blow up the plastics in rigid foam for packaging and soft foam for pillow and furnitures. What does it mean? It means that CFCs were used to blow up the plastics into non-flexible form to make packaging, so that the package won't be distorted. Okay, and by 1970, world production of the CFCs was around 1 million tons a year. In 1985, not so wonderful after all. In 1985, uh, Joe Harman and his two colleagues from the British Antarctic Survey published a paper in the scientific journal Nature, um, warning that ozone was being depleted over the Antarctic and suggesting that chlorine was the cause. Basically, what happens when any scientist works on something, they have to uh, publish their work in journal, so that the other community, other scientific researchers um, can be benefited and aware about the work that has done by any scientist. Okay, so soon everyone was worrying about this hole in the ozone layer, though it was not really a hole. Basically, what they are trying to say that when the Migle was done with working CFCs, Joe Harman and his colleagues worked with CFCs and found out that ozone is depleted because of the chlorine. Okay, so chlorine was indeed the cause, and CFCs was considered as the culprit. So every time an aerosol hair spray was used, or the fridge waste dumped, or a hamburger carton was discarded, CFCs escaped into the air. Aerosol hairspray is basically a liquid in an aerosol or other spray containers for holding the hair in place. And CFCs are the insoluble in rain and unreactive. They eventually rose into the stratosphere, and at low temperatures, CFC molecules are broken down by the ultraviolet radiations, giving rise to the chlorine atoms that will cause damage to the ozone layer. Here you can see in this reaction, trichlorofluoromethane, by the action of the UV, is breaking down into the dichlorofluoromethane and chlorine. The chlorine atoms then react with the ozone molecules, converting them to oxygen, and a single chlorine atom can destroy 100,000 ozone molecules. You can imagine what a threat does it pose to the ozone layer. Okay. Here in this picture, you can see a chain reaction. Chlorine, when reacts with the ozone, produces oxygen along with hypochlorite. Then two molecules of the hypochlorite undergoes a self-molecular arrangement and producing dichlorine dioxide, and then this molecule is breaking into the chlorine atoms and the oxygen atom. So you can see that the chlorine atoms are free after the reaction and are ready to attack the ozone layer. Now, that report in the Nature alarmed the world. In 1987, 27 countries signed a treaty called the Montreal Protocol to reduce their production of CFCs. In 1987, they thought that they have to reduce the production of CFCs, and they have to find an alternative of this, right? So in 1990, it was made tougher. Production should be bent altogether by 2000. And 150 countries have signed this Montreal Protocol, and it wiped. So here in this graph, you can see that this graph shows how the concentration of one CFC called CFC2 increased over the South Pole until around 1993, and is now leaving off. It is now in equilibrium, means this CFC's concentration by 19 since 1993 is not falling or nor increasing. Okay. So CFC molecules take time to rise to the stratosphere. They are still being made in some developing countries. Many old cars have still air conditioning that runs on the CFCs. So it will take years for the graph to fall back to the zero, right? In the meantime, depleted ozone levels have been reported over many countries, and the skin cancers is on the increase. So what's the conclusion? The hunt is on for the CFC replacement, right? And once a new compound will be formed or will be made, it has to pass the test of ozone. Okay. Nowadays, what are we using instead of CFC? Hydrofluorocarbon HFC is being used nowadays in air conditioning as a coolant. Okay. Now I hope you must have got understood my lecture. So it's time to write answers of the questions in your fair copies. Question number 1 is, where is ozone layer? What function it does? Number 2, what happens if the ozone layer depletes? Number 3, what are the CFCs? Give its 5 uses. Number 4, how does CFCs damage the ozone layer? Number 5, show the chain reactions of chlorine atom with ozone molecules. Number 6, does the Montreal Protocol been successful? Thanks for your attention and patience. Me, Miss Subia Yusuf, signing off. Take care. Allah Hafiz.